All right, guys, so let's go ahead and go over this test review. All right, so for the first one, you're giving an estimate of the area shaded. It looks like it is shading 1 standard deviation above and below. Based on our empirical rule, 1 standard deviation is usually about 68%. Again, that's a rounded thing. So closest answer at this point is 70%. Good to go. All right, number 2. Listen closely, because this is what I was talking about how the data actually proves the case that you're trying to prove. Okay, so you have a treatment group that is 64% plus or minus 3, which means they're from 61 to 67%. And then the control group, again, 55 plus or minus 3 means that they're from 52 to 58%. Okay, there is no overlap, right? If there was overlap between them, then it's a possibility that if you subtracted them, like I talked about on the CAT and CAT-F groups, that you would get a difference of 0, right? Which means there's no way to prove. But since there's no overlap in their confidence intervals as far as the estimates, then that actually proves that the treatment is effective. Okay, so that's why that answer is the way it is, and it's specifically because there's no overlap. You cannot do just the maximums and looking at them, because it's possible that the maximum here and the maximum here, obviously this one's bigger, but it's still possible that you could have an overlap between them, even with the maximums, one being higher than the other. So it has to do with the overall overlap. Okay, so this one I went ahead and ran the data like I told several of you yesterday. I went ahead and rounded. I got 31 for a mean, 11 for a standard deviation, and I went ahead and did my, xi minus x bar divided by sigma to get my z-score, right? It was approximately 1. Okay, and if you look up 1 standard deviation above the mean, we know that's 84% or 0.84, right? But it says more than. And if it's more than, you have to subtract it from 1. If you remember, the z-scores count upwards from 0 from the left. So 1 standard deviation above the mean, yeah, that's 84%, but I don't want this part. I want this part up here that's actually bigger than that. Okay, so you have to subtract and get the 16. All right, so the next one, I want a normal distribution with a mean of 170 and a standard deviation of 5. The first 2 answers, and again, if yours are in a different order, that's fine. But the first 2 answers are the ones that have 175 in the middle are gone right off the bat. That's not the right mean. So 170 has to be in the middle. And then if I have a standard deviation of 5, remember that you have to go out 3 standard deviations in either direction. That's 1 if my standard deviation is 5. And that's way too much area for 1 standard deviation above and below. So it has to be the last one because it's actually going out 3 standard deviations in either direction. All right, and feel free to pause, rewind, do whatever you need to do. I'm going quick so I can actually get this set up for y'all and make sure the video is not too long. All right, so they want to know which one is going to be considered approximately normal. All right, so approximately normal, remember, mound-shaped unimodal. So let's go through them. I know the first one is good. It is actually mound-shaped unimodal. Looks pretty symmetric. This one has an outlier. No good. Okay. This one is very specifically skewed to the right because you've had data that's been pulled away from the main mass. This being the main mass, that being the tail. And then the last one, even though these are 2 different heights, this is actually considered bimodal, right? We don't ever have that in a normal distribution. So it has to be that first one or whichever one that was for your answers. Mine, it was on the first. So that is the one that is specifically normal. Okay, so for this one, they want to use an observational study to collect the data, and they want to randomize because it has to be random. Otherwise, we can't apply it to anything. Okay, so you cannot assign half of them to live in paid housing, right? Because what you're trying to check is whether or not living close to campus makes your GPA higher. So that means I would have to assign, if I was going to actually use this, I would have to assign them to live in paid housing and then the others to live in paid housing that's farther away from campus, right? And even then, technically, if you're assigning something, that becomes an experiment, right? So it cannot be this one. You cannot randomly select students with high GPAs and determine if they live within 5 miles of campus or not, because that is not randomized. You would have to pick people with high and would need low GPAs as well to compare. So this one is basically incomplete. Like it doesn't actually have a way of comparing everything. The next one, the researcher selects random observers to collect data. No, on high school students, then compares the GPA. This doesn't even say anything about where they live. So it's no statement about living, like where they live, closer or further away. So that one doesn't work. So it has to be the last one where it says they randomly select high school students who live within 5 miles and ones who don't, and then just looks at their GPAs. So it has to be this one. All right, next one. Okay, so again, I went ahead and set up the math for it. This is a between problem, right? Fall between 315 and 535. So you go and do same formula, subtract the mean, divide by the standard deviation, get your z-scores, right? After you found your z-scores, then you have to look up your percentages and then subtract since it's between. It is closest to 58%. It came out to 0.579 when I did it. All right, so the next one. You are comparing this kid's scores, right? If you're looking at the answers, it talks about which one's the highest, what percentages of that. So when you get a problem like this, the first thing you should do really with every single one of them, since they gave you the mean and standard deviation, find the z-score, find the percentage so that you can actually start comparing on your answers. I went ahead and found all three. Critical writing was the highest, right? So if I don't see a statement that says that critical writing is the highest, they're going to be wrong. Critical writing is at 58%, math is at 55.6, and writing was at 57.5. So those are the kind of statements I'm looking for. So if I go through them, okay, Tyler scored the highest on his math. We already said that was a no. He scored the highest on his, the reading one, I think. Tyler scored higher than 58.3 on the critical reading. That's an actual true statement. So they're looking for the one piece that's true. And in this case, that's what it was. So the other two, he didn't score the highest on his writing. We said that already. And he did not score 58.3 on the writing. Again, if you go back on the writing, he did 57.5. Okay, experimental design will not result in a randomized sample. Okay, so randomized sample, you have a couple choices. Remember, you can, or actually more, you can do stratified, systematic, cluster, and just a simple random sample. All right, so dividing a list of voters into Democrat and Republicans, that means you have stratified it, right? And then selecting every 10th name from each of the two results, that means that you systematically did it. So that actually is randomized twice. Very nice. Selecting every 5th person from the class, again, that is a systematic. Okay, assigning a unique number to every medical student, keeps going. This is literally the definition of a simple random sample. You're giving everybody the same chances of being in it. Using all students from sections 1 and 2 of a statistics course to constitute 2 samples. Okay, it doesn't say anything about how they're put into the 2 samples. It doesn't say anything about any kind of random, which means this is the one that is not random. Okay, next one. All right, so again, mean, median, standard deviation, they basically given you all the data. They want to show which graph basically represents 95%. So you need to remember 95% is 2 standard deviations. So the mean plus or minus 2 standard deviations, that's like 9.8, right? So you got to add and subtract 9.8. So what you should get is 24.9 on the upper end and 5.3 on the lower. That's what you're looking for with the mean in the middle. Now, if I'm not mistaken, all of them have the mean in the middle. So what you're looking for is, again, the one that shows 2 standard deviations. All right. So, okay, a professor has a final average of an 82 on their test, standard deviation of 4. Where does 72 fall? So again, if you need the visual, 82, and I'm not even going to bother going above because the score of 72 is below the mean. So that would be 78, 74, and 70. So a grade of 72 is going to fall about right here. And if I wanted to be specific, I would say it's 2.5 standard deviations below the mean, right? But that's not one of my possible choices. I know it is not exactly 2 or 3, right? And if it was more than 3, then my score would be less than a 70. So it has to be within 3. Okay. Okay, so 20 pre-kindergartner students in her class. She taught them the importance of raising their hands during class discussion, and then she's collecting the data to see how many times they raise their hand. Okay, first off, this is not a longitudinal study. That's like the one I told you from England where they follow those kids' scores for like 20 years, right? Observational study means that there is absolutely no interaction. That is not an observational study. This is not a sample survey. She is not asking them to remember. All she's doing is watching. So technically, even though she only used the treatment group and no control, this is an experiment. All right, same thing. I set up the math for it. You have your choice between doing the empirical rule and doing it with your z-scores, because this is falling on exact standard deviations between 86 and 82. So you either add that and get 47.5%, or you do your z-scores and then subtract and you get 47.7. You're not going to get two close answers like for multiple choice on your test where you have to figure out which one, 47.5 or 47.7. We're not doing that because both of these are an acceptable way to find this answer. So they're just giving you the one that is more exact by using the table. But again, you can do the empirical rule. 47.5 and 47.7 are right there. And you won't have another one you have to fight it with. Nope, that was not what I wanted. Let's try that again. I want that one. Okay, so randomly assigned to a treatment group and a control group. I don't even have to go over this one. That is an experiment. We talked about that yesterday, specifically. All right, next one. Okay, Health Magazine. They want to compile a list of 20 popular flavors of frozen yogurt. The teams visited the shops around the country. Okay, they did not put any treatments on anybody. Here's the interesting part. They actually didn't talk to anybody. All they did was go to the shops, and it wasn't long term. So in this case, it is an observational study. Unless they are actually asking somebody, then it cannot be a survey. Okay, so again, set it up. This is another in between. Got 3 of these on here so far. These should be getting pretty boring as far as setting them up. I know it's a lot of work, but go ahead and do it. It ends up being 69% based on your z-tables. And that is the last one. So behave yourself for the sub. And if you have any questions, you can always send me a question and remind, because I will have my phone with me at the appointments and I can at least shoot off a fast answer for you.